Hi, all the Math CEO mentors. So I know it's the beginning of week 8. You're tired, you're stressed, you've got exams and homework. So I just want to say a big thank you for taking the time to watch this video and get more acquainted with the teaching strategies for the activity this week. We really, really appreciate it. Okay, so on to the actual activity. What are we looking at in the meeting this week? So the activity is titled Math Codes, and I'm going to give a few little teaching tips for it. So first, a little introduction is we've just got these 4 commands: F for forward, B for back, L for left, and R for right. And when you turn left and right, you don't move. And there's a few examples of how to make a cane and a stair here, and I won't go over those. I think a really great idea for this first little bit of the activity is to give students a chance to just work on these questions on their own, and at least 2 to 3 minutes. So after you set up maybe a little game like, oh, we're going to be spies together and you need to send a picture to your spy friends, but you can only use these 4 letters, then you can let them play around on, they'll have a physical graph paper. So I think it would be a good idea to leave this slide up, have 2 minutes of quiet time, and let them try to draw the cane and or the stair using codes other than the ones up on the screen here. Okay, cool. And after they spend a little bit of time trying out each of these on their own, it's good to ask them to share their codes and how they came up with them. And at that point, it's a good idea to introduce this app. So this app is on the second slide. I'll click open here. And Chris Davis here at UCI made this for us. So for example, the code that's given to us for the cane is forward, forward, right, forward. And you can see that it's drawn this little L shape in purple in the bottom left of the graph. And maybe one of your students will suggest the following: back, left, back, back. And it also makes this cane shape. So after they share their codes, you can ask them to explain their reasoning. So this is a reasoning type of question, how they came up with this code to make that shape. And another good idea is if they get at the idea of symmetry, they might not use the word symmetry, but the idea is, I'll write it out. So we've got forward, forward, right, forward, and it's the same as back, left, back, back, right? You can see I've typed both here and I've gotten no new shapes. It's still just the cane. And if you stare at these, you can notice something, right? That it's like I'm reading the first one from right to left, and I'm flipping all the backs to forwards and all the lefts to rights. So they might not use the word symmetry. They probably won't, but they'll be like, oh, I want to flip the cane around or something like that. And then it's your job to be like, oh, this is really cool. This is a generalization. This is a pattern that they can observe. That to get the same type of shape, I can just read the code backwards and flip all the backs to forwards and all the lefts to rights, and it'll get me the same type of shape. So if they don't bring symmetry up, you don't need to bring this up. But if they do, I think it would be really cool to try to ask them what the general pattern is for doing this. And that's like a generalizing prompt. Okay, cool. So the last couple of things I want to say are about the other bits of the activity. So you see the second slide. They're going to write some code for a square. And they can do this on the graph paper, or you can give them the link to this app. And I think it's fine to do either, but I think you should be consistent with the class. Like you should, either they should all be working on the app or they should all be working on paper. It'll just make your life a little easier with getting to look at their things. So they'll make some code for a square, you'll test it out with them. And they'll also create their own code. And I think at this point, this is a really good place to ask thinking questions, which is the focus this week. And a really good one that I like is that to just let them come up with a question for the class. And they might be kind of weird. Like one I thought of is like, can I draw a smiley face with code, right? And that seems unrelated to the goals of the activity this week, but I would encourage you to pursue the strange questions. So can I draw a smiley face using this code? Doesn't seem like it's a math question, but when you get into the reasoning, you realize, oh, I can't draw a smiley face. And what's the reason? Well, my code does not support leaving spaces, right? Like I can't move anywhere without drawing something. And this is why I can't make shapes that have like gaps. I can't like draw on the inside of something. All of our lines must be connected. So that is getting into a math concept right there, even though the original question did not seem related to math. Okay, so I would encourage, if you get to item 3 for creating your own code, let the students ask their own questions, pursue the ones that don't even seem related to math. You can make a lot of interesting things show up. All right, I did want to speak briefly about the second activity, is these fractal temples. So we start with hat, and here's what I'll do. I'm going to copy this. Copy, okay. And we're going to see how the app works with fractalizing. So if you don't know why this is called fractalizing and you're interested, I would encourage you to just like look up a 3 blue 1 brown or like a number file video on fractals. They're very, very cool pop math objects. All right, so I've copied and pasted this code. You can see the little hat has appeared. And I'm gonna click this button down here in purple. The text is pretty hard to see because of the background, but you can see the purple box. I'll click it and it says fractalized. And it's drawn the hat over and over again in a bunch of orientations. What has it actually done? You can see down here. Now let me zoom in. Okay, you can see down here that it's replaced all the forwards with all of the code that I pasted in. And that's why you see so many copies of the hat, right? Okay, so it's like I took the hat and then I rotated left and I pasted the hat again, and then I rotated right and I pasted the hat again, and so on. Okay, cool. And then something that you'll be asked to do is to fractalize this again. And this is what I'll do. I'll copy and paste the fractalized code up here. You can see the same shape has popped up again. And then I'm going to click the fractalize button again. And it looks like we've lost a bunch of nice structure, but it's because our scale is not quite right. So you see the scale sliding bar in the top right. I'm going to move it. I'm going to zoom out a bit. And then I'm going to hit the fractalize button again. Oh, I didn't zoom out quite enough. Let me try one more time. There we go. And now you can see that it looks like I've had a bunch of hats. You can see this big hat. I don't think I can annotate on my own screen. You can see this very big hat cut into the triangle shape. And you can see many smaller hats in each of these shapes. So I don't think you should say that with the students. I think you can show it to them and they'll probably be interested because it just looks kind of neat. But then you should ask like, oh, do you see the shape we started with anywhere in this shape? Maybe that's a very guided question. If you want a much more general question, you can just say, does anyone have any interesting observations about this fractalized version? And so on. So I really wanted to point out the scaling that exists because I didn't catch it at first. So please make use of the scaling and then copy and paste the code as you like. I won't copy and paste this code on Fractalize again because I tried it before I started recording and it made the app freeze. So you should also take note of that. Some things, if they're really, really large, the app won't fractalize them. It just like times out. But you can still make a lot of interesting observations here. Okay. So that's the fractal temples. And for this, you will have them try it on their own first and kind of play around and see what the shape looks like before you go to the app. And then you just want to ask these kind of generalizing pattern-based questions with them. Okay, there's a few more slides. I'm not going to say anything about them because I think I've covered everything I wanted to say. Okay, thank you guys so much for your attention during this time. And I hope you have a lot of fun at the meeting on Wednesday.